Beep, beep, beep.
Waha!
Must be all that cough syrup I had.
Hello and welcome to the HACKADAY podcast. I'm Elliot Williams, editor-in-chief of HACKADAY.
And I'm Dan Maloney. I'm staff writer at HACKADAY.com and community engineer at HACKADAY.io.
This is episode 201, Faking a Transmission, Making Nuclear Fuel, and a Slidepot with a Twist. Do you have any news other than this, or should we just...
My news is that I missed episode number 200, right? We're up one now. We're on the other side of 200. Wow.
It's hard to believe. It is hard to believe. 4 years of HACKADAY podcast, ladies and gentlemen.
Oof. And you're still with us.
I'm not that old, man.
No, not you, them.
They're not that old, man. Yeah.
They've still made the conscious decision to keep coming back for more, so we must be doing something approximately right.
I hope so. I hope we're doing right. This week, Jenny wrote an article about John Deere tractor kind of finally signing a memorandum of understanding with the American Farm Bureau Federation to allow people to repair their tractors, which has been, I don't know if you've been following the right to repair thing, but John Deere has kind of been the poster child for like worst, most restrictive practices. They put kind of DRM-y things on all parts of a tractor, which is particularly galling, I think, for farmers to not be able to repair their livelihood, I guess.
Yeah, geez, allow them to make their repairs. Wow, button up your flannel shirt, your heart's about to fall out.
You got to take it into the dealer.
Oh.
Otherwise, it's a DMCA violation. What's crappy about this is that they have signed a memorandum of understanding saying that they'll, let people do it. And so they're not withdrawing their DMCA encryption tendrils out of the machine itself, but they are saying at least they won't prosecute you if you fix your own tractor.
And a lot of that was probably already going on, if I know farmers the way I think I do.
Certain. It's a victory-ish. It's It's Victor-esque here. It's John Deere has kind of been pushed hard enough that they've stepped back a little bit. And I think that actually is good and is a good model for the kind of right to repair movement to show that you can push hard enough that they'll step back. Man, it's tough that it took that long to get there.
Yeah.
Should we head on to What's That Sound?
What's that sound? Let's do it.
What is that sound?
This is a journey into sound.
What's that sound?
What's that sound?
That's atmospheric of some sort.
Mm-hmm.
It sounds a lot like the morning chorus, but you already did that one, so I don't think that's it.
What's that crazy big thumping whooshy noise?
I'm thinking it's some sort of tectonic noise. Did I get it?
No, you did not. It's from the video game Portal.
Oh.
Did you play Portal?
My children will disown me. They did. I never played it. So they're just.
Tom was like, "Man, I love that game," and I'm like, "Yep, yeah." Someone doesn't pay attention to the sound effects, but
it's very atmospheric. It sounds natural to me. So.
So we got 16 answers in this week, and basically all of them picked up on it being a video game, and most of them were kind of in the right era. Among wrong answers, we got like BioShock, Quake 2, what else? First stage of Half-Life, that's a good one. Splinter Cell. They're all in the right like time zone, but the wrong particular game. But of the 16, 8 of them were right, and 8 means I get to roll an 8-sided die, so I'm pretty stoked about that.
Cool.
Here we go. 7. And that...
Okay.
7, shooting portals and walking around in the game Portal from Blessed Custard Waffler. Congratulations, Blessed Custard Waffler.
Even if you hadn't rolled a 7, you'd have to pick that name.
Man, that's a good one. Now, this is one of those weeks where we got lots of good names. We also got Weary Coder, but with 3s. in lead speak. We got
Nice.
High 555, Neurotic Mnemonic, just straight up Calculus. That's not your real name. Nobody names their kid Calculus. You're not fooling me. And yeah, the answers were all pretty straight up. Sounds like a man pacing up and down in his temporary accommodation at the Ecuadorian embassy. Free Julian Assange. It's possibly the wrongest answer of all, but in some ways the rightest. So good on you, Foley, last name Matthews. Anywho, congratulations are in order to Blessed Custard Waffler. And yeah, we'll have to shoot you an email, get your t-shirt size, and get a HACKADAY podcast t-shirt headed your way. Oh, and the rest of you can listen in next week. We'll do this again. No worries.
Yay.
All right. First up in the way of hacks this week will be UMaker. Classic video chip drives a modern TFT. And this is a really cool hacky hack. He's looking into kind of the chain that would drive a monitor in a really old retro computer. In this chain of chips, the CPU talks to kind of a graphics chip, and then this graphics chip sends its signals off to a PAL or NTSC encoder chip. And what UMaker is doing here is sneaking in between the graphics chip and the TV encoder chip, sniffing the analog signals that it sends to it, and then taking those, digitizing them, and sending them off to a modern TFT display, either in SPI mode or parallel mode. More on that in a minute. But this is a really cool hack because, if you have one of these computers that has a flow like this, you're stuck needing a CRT monitor to watch the output. Here, you can put it on one of those little ILI 9341 little TFT LCD screens so you can make it portable. And that's a really cute hack. What's amazing to me is the way he does it, which is to just listen to 2 of the color channels somehow, and that I still don't fully understand, and run twin ADCs in the chip he's using, which is a STM32G474. So it's, a fairly modern microcontroller, but nothing hyper fancy. And with clever coding and a lot of overclocking, is able to read the analog voltages off these 2 lines directly, infer the colors out, turn these into something then that it can spit off to the display. This kind of technique would be super handy for people using like a modern retro computer like the RC2014 or something like that, which uses a TMS chipset like this to do its graphics.
So was this the chip off of like the TI-99 and like that?
Could easily have been, right?
I'm guessing so from its designation.
It's a Texas Instruments chip.
Yeah, that's interesting.
I mean, think about it. You could drive a, modern digital display off of your old TI-99 if you still have one.
But I mean, doesn't everyone have a CRT monitor lying around that they can use for these purposes? No, I guess not.
No, actually, not at all.
I ditched all mine a long time ago, and I don't know how I feel about that.
But what's really weird about this, and this is the part I still don't understand, so someone can jump in the comments and let me know. The lines coming out of this TMS chip are not RGB. Instead, they're yellow, red minus yellow, and blue minus yellow. And so, it's just kind of like a different color space. That's not so weird. What I don't understand is UMaker listens to only 2 of these lines and infers somehow what the missing signal on the other line is. And I'm definitely confused by the differencing here, but I don't think that's where the bodies are buried. Anywho, I'm still scratching my head. Other places I'm scratching my head are these TFT displays are supposed to run at like 10 megahertz on the SPI line, and he finds that he can run it at 42.8 megahertz, which is a 4 times overclocking, which is pretty crazy. If he runs with the parallel interface, it's no problem at all. It can do full speed, but to get the kind of throughput he needs to keep up with the graphics chip, he has to drive the display at 4 times faster than it's supposed to go, and that works somehow, which is really cool. Oh, and the last bit that I thought was really awesome about this is that he actually slaves the STM32 chip to the TMS graphics chip by taking the crystal that drives the graphics chip and feeding it into a PLL on the STM side. So he's got a multiple, I think it's 16 times multiple of the frequency that is driving the video chip so that he can do the ADC sampling exactly at the right time. And that's pretty clever to actually like wire the microcontroller into the same clock source so that you can be sure you're taking your samples right on. You know, I have to say the results are really awesome. So whatever it is he's doing with these two signals that he does have, you can look at his demo and it is giving you, you know, red, blue, and green. So whatever he's doing, he's getting 3 out of 2. Again, I'm still scratching my head.
The interesting thing here is that Jenny sort of has a hopeful yet skeptical note that that it might actually be able to be used for light gun games like, you know, Duck Hunter or something like that. Those kind of games have not really survived the CRT to LCD transition very well. So too bad, because a lot of those were a lot of fun.
Right.
And maybe this is a way to resurrect them, but laggy, maybe not.
Who knows?
Yeah. Give it a try.
The thing I like about this is all really, really, you know, close to the metal, close to the signals. It's all actually analog. And he puts a microcontroller in the middle of this device and shows how the signals are flowing through. And it just kind of gets in the middle. It illuminates a lot of what's going on. I really like that.
Always cool to get a look under the covers.
Exactly.
My first pick this week is a retro-tectacular that I actually wrote, Critical Code Reading 70s Style. This is based on a film, you know, obviously an educational sort of film that Alec Watson, who runs the very popular and deservedly so Technology Connections YouTube channel, he put this on his secondary channel, which he calls Technology Connextras, which I think is great. On his main channel recently, he had done a teardown of 16 millimeter film projectors and how the sound aspect of that worked. Fascinating stuff. Go check it out if you haven't already. But in the process of doing this, he got one of those Bell and Howell projectors that used to pop up. If you're of my vintage, they'd pop up in the classroom all the time, and that's like the greatest day in the world because we're going to watch a film instead of learning or whatever we're supposed to do. He starts off with a good bit about how teachers hung over today. We're watching a film. Right. And I always kind of got that feeling that there was something going on with the teacher when the film strip or the film projector came out. But anyways, so this is by an outfit called Ethnotech, which was helmed at one point or another by Gerald Weinberg. And it's kind of an earlier than you would expect example of looking at code in a structured way. In fact, that's the name of it, Critical Program Reading, Structuring, and Unstructured Program. The outfit's called Edutronics, and apparently they put together a whole bunch of films that are like this about coding, and this is around 1975. It kind of struck a chord with me because this was this topic was sort of near and dear to my heart at one time and became not so dear as the way I made my living for 20 something years was basically writing code. I was always keen to employ as many, I'm not trained as a coder. I didn't get a software engineering degree. I didn't get a computer science degree, anything like that. I just learned by the seat of my pants like a lot of us. But I was always keen to employ software engineering principles as I understood them to try to make my products better and last longer and improve them when they failed. I would learn from what failed and try to get better at it, This is about taking an unstructured program and making it structured. What this is focused on is a bit of pseudocode, which was supposed to be a kind of a combination of COBOL and PL1 plus, not code at all, just sort of pseudocode. And these 3 Scooby Doo villain looking characters that are animated in this film go through and try to restructure this, refactor this code and give it some structure that makes it more understandable. At some points, I'm thinking one of these guys is going to tear their mask off and say, if it wasn't for you, I would have gotten away without refactoring if it wasn't for you meddling kids. But no, it never happened. It's kind of cheesy as far as content and animation goes, but it still has a lot of really cool, pertinent, relevant tips that we all mess up as we code something up quickly to make an Arduino program or a little Python script to do something, blah, blah, blah. We all fail at these rules. And maybe if we didn't, our code would be a lot more readable and maintainable by the next guy, because invariably the next guy is going to be you.
Yeah, right.
And the comments section is great in this one because readers were saying, that's not refactored, this is refactored. And they would go through their own implementation of how they'd make. I have a feeling it's going to be like the Perl programs that eventually become one-liners that are just line noise that nobody can read. Somebody's going to get this cleaned up to that level at some point. But great find by Alec, putting it out there. I don't know what the copyright situation is on that. That's for him to worry about. Hopefully it doesn't get taken down, because it's really worth watching and a lot of fun.
The original example is horrible, and the fact that he kind of makes these people go through this is really funny in the video. But what they come out with are surprisingly kind of modern recommendations for how to do programming. Like none of this is bad advice. And, they start with this code that has just such horribly abbreviated variables that nobody even knows what's going on. And it's like, okay, we're going to name these all something reasonable. And that is like one of the hardest things for me to do. I always try, I was taught at one point in time to make all like variables nouns and functions that do things verbs, right? And so that it kind of reads like a sentence. And I do that most of the time, some of the time. But the problem is that it really is hard to think up good descriptive variable names for everything. And it's shockingly important. Even though, of course, for the computer, it doesn't make one bit of difference. The computer is like, oh, this variable is number 1. This is variable number 2. But to the people reading through it, it makes a difference between you have a little bit of a foothold and you have absolutely none. I don't know if they said it in the video or not, but I always go through at the end of code I've written and I think hard about the variable names again. Because sometimes what that variable does changes as I'm coding it. And I know I should like block stuff out better beforehand. And I'm just a sloppy coder coding as I go. And that's true. But at least when I'm done with my sloppy coding as I go back and I'm like, okay, well, what was that variable actually? And then rename things and just do a quick, it doesn't take 5 minutes to do a quick refactoring once you know what everything does and where all the pieces go. And that helps tremendously later on. And he says something like this in this video. So good video.
It's been a long time since I've been a daily coder, but I still remember, needing to find a particular section in my code and looking for it visually, looking for the pattern in the code. Like, oh no, this can't be it. The lines are too long. Oh, well, look, here's the switch case. It's a nice long switch case or something like that.
Yeah.
And eventually finding it just by the shape of the code. And I thought maybe it was just me being weird, but I talked to other people and they're like, oh yeah, no, it's. Same thing. I recognize it by its structure.
We've evolved to be able to get through forests this way.
We're pattern recognition machines, exactly.
All right, this is a niche hack if I've ever seen one. This is Spaceballs Get Serialized, and Evan has one of these absolutely marvelous Spaceball 3D controllers. And I actually am a big fan and have one here right at my left hand now of the Space Mouse, which is the precursor and actually post-cursor to these Spaceballs. But the Spaceballs are so lovely. And you really, if you've never seen one of these, we included a video that I guess is from Adafruit of her just playing around with one. They're so like 90s futuristic. They're so awesome. But what they do functionally is they let you tilt the thing, twist the thing, move it back and forth. You actually have full 6 degrees of freedom manipulation. And if you're doing like CAD programs or something, it's absolutely the best thing since sliced bread to be able to manipulate an object as if it were in space. They're super fun. These Spaceballs are really old and they used a serial interface. And so Evan wanted to use another project, the Orbitron 9001, which is actually a really cool looking project. You'll find the links if you follow along. And this is a little hardware device that takes the serial output from the Spaceball and converts it to USB HID 6 degree of freedom motion controller. And so this is sweet because it's a little hardware device that you can plug into these obsolete but fantastically awesome and very cheap and easy to get devices on eBay. And it turns it into a USB device. And that's pretty darn cool. In this case, there are two different versions of the Spaceball, the 2003 and the 3003, and one of them didn't work with the converter in question. And so that's what Evan's hacking on here, and he hacks it to make it work with the Spaceball he's got. Anyway, like I said, I am a total Space Mouse fan, and if you are running Linux and don't want to deal with this whole serial to USB connector, I recommend to you free SpaceNav, and they have a daemon program that you can run that makes the serial Space Mouse work with your computer. And so all you need is a serial USB converter, and that works just fine. And that's a sweet piece of software. It's been working on the USB ones for a long time now and has only been working on the serial ones for the last couple years. And I totally recommend it.
Got to point out the complete lack of ludicrous speed references.
Yeah, right?
In this, Matthew, come on, step it up. you gotta say ludicrous speed somewhere here. It's interesting that this is the controller that was chosen for driving Sojourner on Mars. That's really cool. And I can also see how, and I think you even mention it, or he even mentions it here sometime, but yeah, the rubber coating on those balls must just feel awful after all this time.
The virtue of the Space Mouse is that it's got a plastic thing that you turn and move, so it actually doesn't get cruddy.
Yeah, and I don't know that there's any way that you could really clean something like that if it's been grodied up,
Oh, but I totally want one of the ones with the, like, space ball. It's just so rad looking.
That is extremely rad looking. And of course, you and I are both kind of trackball nerds anyways.
Yeah.
So we like the alternative inputs.
Yeah, I should really do a story on these because I've picked up a number of them from eBay and I've taken them apart. I've actually done some of my own interpretation of their serial protocol myself. You can actually find the programmer's manual online if you look for it. Magellan Programmer's Manual 2000.pdf. is what you're looking for if you have one of these. And it tells you all of the dirty details. For instance, the thing just speaks serial, so it talks at 9600 baud, no problem. It encodes it every 4 bits, so every nibble is encoded into a byte, and it has this weird checksumming scheme where the first nibble is either 3 or 4, depending on the number of ones in the second nibble. And so it ends up, the cool side effect of this is that all of the data coming out of this thing is printable characters, but you have to know to interpret M as 7, question mark is 15. These are weird devices, but they're also so awesome. And the space is legit. Actually, they were designed originally by the German equivalent of NASA, the DLR, and actually not far from here where I am in Munich, actually out by Wesslinger See, not even far away from where I am right now. And they were originally created to run the Canadarm on the space shuttle.
Oh, really?
Because they had this many degree of freedom articulated robot arm, and they had to control it somehow. And so the German Space Agency made these 6 degree of freedom controllers and then spun off a company to sell them because they were awesome, and then sold it to Logicad first and then Magellan second. I don't know. Long history on these things, but they're really fun. And if you look online, you can pick them up cheap. And if you don't want to mess around with any of the software side, this thing that Evan did here, where he uses this hardware dongle to convert it to USB, is actually pretty awesome looking.
9600 baud, you say? That sounds like ludicrous speed to me at one time, right?
Ouch.
Okay, next up for me is replacing your automatic transmission with a bunch of relays. I will cop to a little bit of clickbaiting on this title, maybe, because it's not really what it's advertised as. But then again, it kind of is. This is a spoof for a 2003 Volkswagen Eurovan that Dean Segovis has. This particular vehicle is near and dear to him, and when its automatic transmission, which is a known failure point in the vehicle, when that finally shuffled off this mortal coil, he decided that he wanted to put a manual transmission in it. Now, there's a whole Eurovan community, makers, hackers, fixers, users, drivers, and I guess this is a popular upgrade, I guess downgrade. I don't know which way you want to call it. Retrograde. And putting a manual transmission in, obviously, you better gas mileage, more control, all the things that we've talked about gearboxes before. Christina did an article on that not too long ago on the attractiveness of manual transmission. So anyways, he wants to put a manual transmission in this, but the transmission control unit would look at all of those dangling connectors that used to hook up to solenoids and sensors in the automatic transmission that's no longer there and say, danger, Will Robinson, this thing doesn't have a transmission. His diagnostics or his OBD was telling him there were something like 14 different codes that were being set, and obviously the vehicle wouldn't run. So Dean noodled this for a while and came up with a rat's nest of his prototype was originally a kind of a rat's nest of regular automotive relays, the kind that would, turn your headlights on and off and things like that, wired up in place of the solenoids that would be actuators inside the automatic transmission that's just not there anymore. And it worked. As far as the TCU was concerned, the solenoids were still there. It was reading the appropriate voltage drop across the coil. Plus, there were a couple of sensors that he needed to spoof, and he also needed to do a little work on the multi-function switch that's on the steering column. But once he got all that sorted out, or as far as his Eurovan knew, its TCU was convinced that there was still an automatic transmission in there. He neatened up everything, the original Rat's Nest prototype, and built a PC board, an enclosure, a nice rack for the relays. Basically, there's an extra relay because he only needed 7, but he put 8 in because it's always nice to include a spare. Wired this up to the original wiring harness, and again, as far as the vehicle knows, it's got an automatic transmission. I thought this was wonderful. I love the idea of, forget about it. I'm not going with an automatic. I'm going with a manual. And convincing the vehicle that it was there in this way was just super, super clever. I also kind of wonder, since the solenoids that these relays are replacing were intended as actuators in the transmission, various functions in the automatic transmission, I wonder if this box kind of clicks as he goes along. It must. You're applying currents and getting the feedback and all that must at some point actuate these relays. I wonder if there's anything to be learned by monitoring the contacts in there. Probably not at this point, but still, it's a really nice workaround for a problem that was keeping him off the road because the check engine light was coming on. He couldn't get California registered and all that stuff. I wonder if that necessarily stays true when a mechanic opens up the hood for the inspection and sees this strange block of relays.
Or he's shifting and it goes click, click, click.
As long as the light is off, most mechanics are probably going to fill out the paperwork and say everything's cool, I guess. Right. Anyways, hats off to Dean for this one. I thought this was a great workaround for a problem that was keeping his van off the road.
I wanted to talk real quick about New Part Day. It's a brand new ESP32 chip, the ESP32P4 Espressive RISC-V powerhouse. And this is a crazy new chip coming out of Espressive. Or I guess I should say system on a chip, because it's got a lot of other peripherals, some of them fairly high-end on board. When I say ESP32, 99% of you out there have Wi-Fi in your head, and this is one of those weird Espressive ESP32 chips that doesn't have Wi-Fi. I guess the 32S3 also doesn't have Wi-Fi, but has some higher power peripherals in its place. This one is in that vein. It's got two RISC-V cores, both running at 400 megahertz. So it can crunch a pretty serious workload. It's also got a 40 megahertz RISC-V coprocessor on board so that you can do low power stuff. And I think that's a really neat blend in that you can kind of run the normal, end quote, microcontroller core when you don't need it to be doing heavy duty stuff, and then fire up the 400 megahertz beasties when you do need to crunch numbers. It's got a ton, 768K of on-chip RAM. It's got a neat set of peripherals that hints at kind of what Espressif wants to do with this chip. It's got a hardware H.264 encoder. It's got enough pins, and I think it's got a MIPI interface to do camera things. So it looks like it's set up to do some video encoding. They have their AI processor hardware thing in here. I don't know much about that, but it makes me think that they're aimed at doing like image analysis with it. For hackers who don't want to do video stuff, it also has 50, count them, 50 GPIO pins. So if you have something that's super IO intensive, this may also do for you. It looks like a really neat chip, and we don't know pricing yet. This is a brand new announce, so who could tell if it's going to be the right chip for your next project. But with two 400 megahertz RISC-V cores on board, it's going to have a lot of grunt, and with 50 GPIOs, it's going to have a lot of interfacing. So that's kind of a neat combo for like my purposes that I haven't seen in this space. And then I do think all the graphics stuff is going to make it neat for people who want to do video or cameras with it. The previous ESP32s and the ESP8266 all use these cores they licensed from Extensa. And it's not a super well-known CPU core licensing company. Like, I'd never heard of them until Espressif picked them up and started using their stuff. So it's interesting to see them make the switch in a chip like this to a fully RISC-V, a core that they can own themselves. So I think that's neat. And Jenny's suggesting that maybe this is the beginning of their transition away from the relatively obscure Extensa toward the new hotness, which is probably RISC-V, because it's open and they don't have to pay licensing fees to run the CPU once they got it designed.
In the comments, I'm seeing some potential alarm for the H.264 and how that might, affect licensing of products. I don't know anything about that, but I think that's an interesting point that people pick up on, that maybe this puts this in a different kind of category for open source hardware. Maybe it just doesn't work for open source hardware. I think that's what they're getting at anyways.
At the end of the day, it's Espressif who has to pay for the licensing, not us. I mean, or maybe we do. Maybe they pass the costs on to us. But anyway, at the end of the day, the hardware on board is what it is. And if it's doing H.264 and they need to pay for it, I presume they have. I don't know if I see this as any more of an issue than like when you use like a LoRa radio. It has to pay for the IP to use the LoRa encoding. Here you have to pay for the IP that's embedded in the silicon that does the H.264. I don't know.
Yeah.
Meh. I remember when the first ESP32 came out, we're all like, okay, this is what this thing is. And then the next one came out and it didn't have Wi-Fi on it, or it had a different number of cores. And we're like, oh, what does this all mean? And they really are loading a lot of the functionality into those last two letters. So this is the ESP32-P4. And don't you forget it, because if you buy the wrong one, it's not going to have Wi-Fi, or it's not going to have 50 pins or. So pay attention out there, y'all. I think this is actually a really neat niche in terms of being a really fast chip that has a lot of peripherals. It's kind of like the IMX chip that they use in the Teensy in a way, in my mind. So we'll see what the hackers do with it.
Send in your projects. Well, when it comes out. Last up for me is a clever mechanism that makes a linear control from a rotary Hall sensor. This really tickled me, and I couldn't really place why at first, but then I realized that the mechanism here that Nixie Guy came up with, also known as Electronic Mercenary on his blog, this mechanism was very familiar to me because I spent many, many hours in the seat of my dad's lawn tractor cut in our backyard, many years ago. And the gas cap for this tractor had a gas gauge built into it. It was exactly this mechanism other than, it being in a gas tank. The details of this one are basically that he wants to build a hands-on throttle and stick sort of controller for Star Citizen. Finding none of the commercial available options being acceptable to him, he went with, roll your own. And it required a 100 millimeter linear control as a throttle, basically. Didn't want to use anything with brushes, didn't want to use anything with wipers, had a whole bunch of specifications and plus the 100 millimeter long thing that didn't really fit into any commercially available at a reasonable price control. Now you're thinking, for a linear control, the first thing you think of, especially even in that range, that 10 centimeter range there, linear pots from like an audio console. Should be able to get those, right? Well, yeah, but again, didn't want any wipers, didn't want the maintenance hassle, I suppose, is probably where he was going with the thought. Also wanted it to be an absolute encoding scheme, so didn't want to have to do any homing or anything like that. So what he came up with was a twisted metal bar that goes through basically, I think, about 170 degrees of twist over its length, approximately 100 millimeters. This bar gets supported on both ends by bearings. On one end, is attached to a I'm going to get this word wrong, diametral, a round magnet. The kind that's used with Hall sensors to detect position when it rotates. The kind of Hall sensor that'll give you it's not just an on-off for your magnetic field, but it's actually going to give you rotational information. So that's affixed to one end. The bar rotates thanks to a slider that has a narrow slot in it that runs up and down it and turns it through 170, approximately 180 degrees, as this slider is translated up the length of the twisted metal bar. I just thought this was beautiful, and that's exactly how this gas gauge worked that was in my dad's tractor. It had a twisted metal bar that went down through a cork, basically, that had a slot in it, and as the fuel lowered in the tank, the cork moved down and rotated a needle through a 270 degree arc on the top of the gauge. And that mechanism always fascinated me, and so that's why I kind of latched onto this one as thinking it was a super, super clever idea that gets him to a control that's not easily available, but is still simple to build. He used a CNC mill and some thin aluminum sheet to build the enclosure and to cut out the metal bar, which then he just twisted with a couple pairs of pliers. It's a prototype, so it's dodgy at first, and some people were kind of taking him to task a little bit in the comments about the mechanics of this whole thing. But you got to do a proof of concept, and I think that's exactly what he's done here, and prove that this kind of thing can work. And translating linear motion to rotary with a Hall sensor is something I wouldn't have thought of, but probably should have, having spent so much time on that lawnmower and so much time filling the gas tank on that thing.
This is one of those hacks that's just totally facilitated by the current state of play of technology, because those rotational Hall effect sensors are now cheap enough that you can afford to just make a potentiometer out of it. And that's what I love about this, is it's using something that we have now that maybe in the days of old slidey carbon potentiometers we didn't have. Like you said, there's a lot of people being very critical in the comments, I think, because this is such a cool and interesting idea. Everybody's like, oh, I want to think about this more. Some people are worried about linearity, but again, that's a matter of mapping in software, so he can calibrate that out if he wants. Some people were worried about slop in the system. Yeah, maybe. I mean, Nixie comes in and says himself that he can make it kind of arbitrarily tight by using Teflon pads, and that's probably true. Someone else suggests you could spring load it. That's probably also true. It's just such an awesome mechanism, though, that everybody wants to come in and figure out how to improve it. I think sometimes these sort of comments come across as people being picky or nitpicking or trying to do something like that. But I think what you have to know, and especially Nixie, if you're out there listening, is that these are people who thought it was cool enough. It really sparked something in them. And they're like, oh, but you could also do this. Can't stop themselves from saying it. I hear that. But it really is just such an awesome mechanism. And it's funny because Voya Antonich comes in and is like, that's the way a fuel gauge in a boat of mine used to work. Go. And you have this example with the lawnmower. Someone else is like, I've never seen one of these before. How is that possible? To me, it was totally new, totally marvelous and just a really great way of A, turning linear motion into rotational motion, and then B, coupling that with the Hall effect sensor. Boom, done.
The interesting thing about the comments is people didn't seem to really understand that the constraints that Nixie Guy had on this one were his constraints, were they're artificial constraints. And that's okay. That's him. It doesn't have to be you.
Yeah, you say what you wanted to do, you get to make it do what you wanted to do.
If you want to put a multi-turn pot on the end of it rather than the Hall effect sensor, go nuts. That's fine. If you don't have the constraint of no brushes, no wipers, that kind of thing, fine, do that. If you want to put an optical encoder on there, an absolute optical encoder, that's fine. It's going to work. The other thing that's nice is you have two ends. You could do two different things at each end. You could have a sensor at one end. You could have a motor at another. That was one of the comments in there.
Ooh.
Nixie thought maybe, it wouldn't be back drivable too well with given basically what a very, very shallow pitch lead screw that this thing rides on.
Yeah.
So that might be a non-starter. But still, wouldn't that be cool if you had a control like the pots in an audio console that go to their presets automatically? If you had a brushless motor on one end or a stepper on one end and a sensor on the other end, you could have some pretty cool stuff. You could even do almost like an audio taper. If you had a way to manufacture in a consistent but differing pitch to this twisted metal bar along the way, so it's more twisted at one end than it is in another, you could maybe imitate a logarithmic taper.
God forbid, just do it in software. You've got more resolution than you can use here. Just do it in software. It's easy.
Essentially infinite resolution.
Yeah, it's lovely.
Just thought it was great. And it's been a while since we've seen anything from Nixie Guy. I think he said it was like 2 years since he's posted a project. I had forgotten that he was in my my RSS feed when this one popped up. I was like, oh, cool. And hopefully we'll see some more stuff on this and other projects that he's got in mind.
My first quick hack, variable width 3D printing the hard way, is a crazy hot end. It uses 7 different extruders and pushes filament through a common nozzle. And then Lictra, the company that makes these, drives either one of the 7 extruders if you want a really thin bead, or all 7 at once if you want a thick bead. It's a very out-of-the-box solution to variable width printing. Next up, IamHex, an open hex editor for the modern hacker. We've seen a number of people hand us tips to this hex editor before. Tom finally wrote it up. This is a long-running software project by Werewolf. This is definitely the fanciest hex editor I've ever seen. It integrates with the Capstone disassembler, lets you save bookmarks, lets you do custom color coding, all the fancy stuff that you could ever want to do with a hex editor. Tom says you may not have a favorite hex editor. I do. It's XXD. But if I needed something fancier, I would give IamHex a look. Next to last up, Alexander Williams' Fourth Cracks RISC-V. This is the story of a very small Forth programming language for a RISC-V platform. I just love Forth. This is a Jones Forth dialect, which is a particularly simple one. If you want something with more bells and whistles, also on RISC-V, you should check out MeCrisp Quintus. Anyway, there's awesome discussion between Alexander and Matthias, the author of MeCrisp, in the comments. They're both like comparing notes. I love to see that. Warms my heart. Last up, Jesse. Can AI replace your Dungeons & Dragons Game Master? No, it can't.
Up first for me, a practical glue stick oscillator. This is by Nick, M0NTV. Thought this had something to do with hot glue sticks when I first saw it, but no, it actually has to do with the glue sticks like the kind you use to smear up your bed of your 3D printer or put 2 pieces of paper together. They're kind of like a big chapstick, big forbidden chapstick. You don't want to put it on your lips, although paste is delicious, but I digress. Anyways, this is about using the mechanism that's inside that giant chapstick for making a tunable inductor for ham radio. basically take the glue out, keep the little cap that went inside and rides on what's essentially a lead screw that's turned by the little knobby thing at the end. Attach ferrite core to the glue base, wrap some wiring around the outside of it, and bam, you got yourself an adjustable inductor. That also doesn't really couple with your hand while you're tuning it, so you don't have a problem with drift. Next up, Myceliotronics, biodegradable electronics substrates from fungi. This kind of reminds me of the line from The Graduate, Benjamin gets advised to go into plastics. I think for us, the word isn't going to be plastics as the future material. I think it's actually going to be mushrooms. And I don't mean that jokingly. I think there's probably a lot more utility for mycelium than people give it credit for right now. What's going on here is basically they're taking regular PCB substrate material, which you would think, normally think is a glass reinforced epoxy or a phenolic resin or something like that, all of which present recycling problems when they reach end of life. This material is basically extruded mushroom that's squished down and coated with copper and used as a PC board and then can be recycled at the end. I think that's kind of interesting, and I'm looking forward to seeing where this one goes. Last up for me, low cost 433 megahertz door sensors get open firmware. I love these kind of projects that find the cheap little bit of electronic gear that's still got some life in it, but has been obsoleted because whatever service or whatever ecosystem they were part of no longer exists. Basically what these are the kind of sensors that you would put on a window or a door or something like that. It would wirelessly talk to an alarm system, which will then connect to the internet and sell your information to the highest bidder. If you don't want that going on, you might need to flash the firmware, and Jonathan Armstrong figured out how to do it on these $4 AliExpress buys and added some new functionality in the process. They transmit a heartbeat, and they also tell when the internal tamper switch has been, tampered with. I think it's a good way to put old IoT stuff back to work, and I always love a good reverse engineering and firmware flashing story.
All right, that brings us to the can't miss articles. These are long form pieces written by our fantastic HACKADAY writing crew. And this week I picked Ask HACKADAY, What's Your Worst Repair Win? From Dan Maloney himself. Mm-hmm. I just love the premise for this one because I think it's something that we've all experienced. You go out there and you're like, oh, here's a problem. I'm so excited to solve it because maybe this is going to be the problem. Maybe that's going to be the problem. Maybe it's going to be a hardware fix. Maybe it's going to be a firmware fix. To steal Dan's punchline straight off the bat here, the first one, it was, one of the power lines had come loose, right? Like the positive lead had broken off. Wah, wah. And this was potentially like a radio fix, or it was the PIR sensor, or it was the microcontroller. There's all sorts of awesome stuff in there, and it was the battery connector. And then there's the other horrible kind of fix, which you call the spicy stove, and your daughter's getting shocked by a stove element, and then you switch them around, you wiggle it, you replace one for the other, and then it works again just fine. And who hasn't suffered through that one, right? It's kind of the hardware equivalent of turn it off and on again, except it's like, I don't know, I just moved stuff and now it works again. What did I do? I don't know. I have had both of these happen to me, each of them a million times. And I think it's really funny that you identified that, named it as a source of discontent, and wrote about it. I just love that. I totally identify.
And literally, after I finished writing this article, I went out. My son was going back to college. It's time to start a new semester. I took his car for a ride just to give it a little shakedown cruise, get him some gas, and it was wobbling all over the place. I'm like, oh no, what's going on? And he didn't report anything to me. And he normally, anything goes wrong with the car, he tells me something feels off. And then I didn't know, I was like, oh man, something's loose in the front end. There's, I did the ball joints not too long ago, so it's probably not that. Maybe it's the upper ball joints. Maybe it's the tie rod ends. I don't know, blah, 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 blah. It's pouring rain, so I go out there, it's freezing, and I jack it up, and I take off a wheel, and I look, there's nothing on that side. There's nothing on the other side. I'm like, well, I'm just going to rotate the tires and see what happens. So, back to front, right to left, jack it up, do the whole thing. The problem goes away. And here I am, I'm thinking, well, what's the problem? Well, the problem is obviously on the tires that are on the back now. So I look at those. One of the tires was low. It was like 10 PSI instead of 35 PSI. And I was like, really? That's all it was? Here I was, in my mind, I'm thinking, I'm going to do tie rod ends. I'm going to learn. So maybe I'll get to buy a new tool. Like, nope. All it was, put some air in the tire and go get the tire fixed when you get a chance because the valve stem is leaking. Jeez, I can't win. I can't lose for winning, or I can't win for losing, or whatever. Don't get me wrong. I'm glad for the fixes that are not terribly impressive. It wasn't that long ago that I tore the top of the motor in this car off completely to get to 2 knock sensors that needed replacing because they were legitimately bad and they needed replacing. It was a huge job, but I did it, and it was, I was really proud of it, took pictures, all that stuff. I've gotten plenty of big wins in the history of this car and our appliances and my house and people bringing stuff over to fix and all that stuff. I've gotten plenty of that stuff, but every once in a while, just like you get yourself all psyched up, like for this transmitter of this driveway alarm, you get yourself all psyched up for it, and it's just a broken wire, like, Come on. I'm really happy to see all the comments here.
Yeah.
People seem to have misunderstood it to some degree because I probably could have worded it better. What's your worst repair win? Because people are telling, wow, there's a time I had to clean out the toilet and stick my arm down there. And like, well, yeah, that is bad, but you won. And I get that. That's fine. I want to hear those too. But what I meant was, what's the one that, that you were so psyched up for that, you were going to impress whoever it was. And, it was like, oh, well, I'm going to change the batteries or,
Yep.
So that's kind of what I was going for. In the comments, everybody kind of focused in on the stove. They're like, buy a new stove. Like, yeah, I know. I really would like to do that. So, and I mentioned that to my daughter, and she said, oh yeah, well, they can start a GoFundMe then for me. I think we're just going to replace that stove and be done with it. I would like to know what the problem is in it right now. It's still, like I said, it's still a little spicy. Some people have said the sockets that the elements plug into might be the problem. I looked, I didn't see anything. Would I necessarily see something? I don't know. She did mention that there's a problem with the oven, that it doesn't heat up very fast. So that could actually be a shorted element in the oven that's finding a path to ground. So maybe she's only getting shocked when the oven is also on top of the stovetop. I'm not sure, but the best thing at this point is she does enough cooking. She's got a family and all that, let's just get the damn thing out of there. So she's got something that she can use confidently every day. I've taken your advice. I'm going to do that.
Oh man, it's probably
costing me money.
It's probably the right thing to do, but
yeah, it is. It's great to do an Ask Hackaday because, first of all, in this case anyways, you get to tell a story. It's nice to get those stories out there in front of people, but then, you turn it over to the readers. What's your opinion? Have you had anything like this? Blah, blah, blah. And, the comments, it's a dangerous ground to go on sometimes.
It is.
And you're a writer because you're going to find out about all the time, all the misspellings that you let slip through and all that stuff. And that's fine. We appreciate that because, we're human, most of us. But there's 146 comments right now. One of them, scroll down not too far. It starts off as a GE repair tech.
Yeah.
Check to make sure and blah, blah, blah. And go on. And the handyman jam. Thank you. All right.
Yeah,
you're
exactly.
the person I wanted to talk to, someone who's actually, this is a GE stove and someone with experience. This might be not grounded properly. This, blah, blah, blah. I love the fact that no matter what we write on, some expert somehow manages to slip into the comments. It's the same way on the Hack Chat. We have, we bring on someone, and I think it's the most esoteric possible subject that we're going to talk about, and bam. Well, I'm actually the guy who invented that in, 19-tickety-2, and it's great to know that those kind of eyeballs are on our stuff. And it's intimidating sometimes because, the people who know way more about it are out there reading what you're writing. But it's also great to be gut checked a little bit on that and to get this great kind of feedback that, I'm going to go over there this afternoon and, look at the things Handyman Jam says I should look at, possibly fix the problem or just throw a new stove at it. Okay, my can't miss this week is Maya Posh's intricacies of creating fuel for nuclear reactors. The engineering problems of creating fuel to go into into the heart of a nuclear reactor. Exactly the kind of thing I used to read HACKADAY for, and exactly the reason I wanted to start writing for HACKADAY, because I wanted to be able to do the research on something like this. I'm surprised I didn't think of this myself for my own self, because this is the article that I would want to have written, because I know how much more Maya probably left on the cutting room floor after doing the research for this, things you just can't put in, the cool little bits of information that you come up with would all be red meat for me. I love this kind of detail. This article didn't really disappoint on that stuff. It's full of all kinds of interesting stuff. I think the line was, you don't back a dump truck full of uranium up to a nuclear reactor and just dump it in like you do in a coal plant. It'd be nice, but that's not the way it works. You really have to engineer this fuel. Chemical engineering, mechanical engineering, and of course there's a lot of electrical engineering that goes into, turning and making a plant do what it's supposed to do. But there's a lot of engineering that goes into taking that raw uranium ore and turning it into a usable fuel pellet. I think now that I've read this, I might have to do a mining and refining piece on uranium.
Ooh.
She does touch on the fact that a lot of uranium ore comes from Australia, Kazakhstan, Canada, that kind of place. What the ores are, that kind of stuff is interesting stuff to me. So possibly I'll think about doing a mining and refining to kind of follow up on this one. What you're basically after for fuel pellets is U-235, the isotope that is used in power plants. It's not a simple process turning that or those isotopes into usable fuel. There's some enrichment possibly. I was surprised to learn how low enrichment most nuclear power plants are today. It's actually not, it's only a few percent of U-235 can be used as fuel. There are highly enriched versions of reactors that require more, a higher purity fuel. But whatever the case is, whatever purity it's required to get to, the process of making fuel pellets, which are, again, this is one of those things where there's a ton of different, you've got pebble bed reactors, you've got pressurized water reactors, boiling water reactors. It's a whole alphabet soup of acronyms and everything varies, but basically you're trying to make a pellet that's like a centimeter long and maybe 8-9 millimeters in diameter or something like that. You're making these fuel pellets out of powdered uranium oxide and sintering that together under huge pressures to make a sintered metal product. Basically ceramics, and that's handy because you're talking about the inside of a nuclear reactor. Things are going to get a little toasty in there. The pellets, the fuel pellets themselves are coated with a zirconium boride, I think it was, coating, and the fuel rods themselves are tubes of zirconium alloys. That's interesting to me because, what's zirconium? Where's it come from? Again, now I'm thinking about another mining and refining piece. So, okay, that's the way these things go, one thing begets another. I also kind of had a side quest question answered by this piece, which was nice. It turns out that they add gadolinium to the sintered uranium as a neutron absorber. And that was a light bulb moment for me. It's like, oh, well, that's why they use gadolinium for MRI contrasting, because it's a neutron absorber, and that would obviously act as a contrast agent for magnetic resonance. So yay, I got a little question answered that I always kind of wondered about.
Can I admit in public that I'd never heard of gadolinium before until reading this article? I'm like,
boron, gadolinium, niobium, iridium, and strontium, and silicon. Oh my God, I'm singing on the podcast now.
I'm like, what is that? And I'm looking it up, and Wikipedia confirms, although it could be Maya's plot here to fool me into believing in gadolinium. But
the great gadolinium conspiracy.
Yeah, new element to me, but
there you go.
That's super interesting.
Nuclear reactors have to be refueled. I mean, that's really basically the whole point of this, is making the fuel so that you can put it into a reactor and make energy. They have to be refueled, and there's the process of removing the fuel rods and putting new fuel rods in. These fuel rod assemblies are also apparently moved around in the reactor to optimize the output. And I guess there must be positional differences within the stack that control how much uranium is burning in the fuel rods over here versus over here in the middle. So kind of like, when you're making cookies and halfway through you want to switch the trays around, you kind of got to do that with a nuclear reactor too. And that mental image is just kind of neat. You should go check this article out and maybe stay tuned for a follow-up on this that goes into more depth on uranium and gadolinium and zirconium and all the other EMs. But the engineering that's involved in all this is a great story, and you should check it out.
Sold.
So what, I got four OCs right here.
Yeah, good job. You've gotten yourself working for the rest of the month. Good job,
Cool.
man.
Lucky me.
And that's it for this week's Hackaday podcast. Thanks very much for listening. If you'd like to get in on the discussion or read the links, head on over to the show notes, hackaday.com/podcast. If you see anything cool or do anything cool, drop us a line, tips@hackaday.com. And until next week,
Keep on hacking.
there we go.
And I'm Dan Maloney. I'm a staff writer at HACKADAY.com. And what the hell am I? Don't get my hopes up. Software engineering principles. Failure alert. Scroll. Next up. Oops. Here we go.
433 is underused. I picked your piece. Haha. I can't say it better, so I'm not gonna.